Hello everyone, welcome to another video on integration. In this video, I'm going to be looking at advanced techniques of integration. Please do not forget to share these videos, like them, and subscribe if you haven't done so already. Provide feedback. We truly value your feedback. All right, so let's start with our first question then. We are required to integrate the integral of tan inverse or the inverse tan of 3x dx. Now, the approach to this one is as follows. So question 1, let's capture it exactly how it is. Our answers will be as follows. Question 1, it's the integral of tan inverse of 3x dx. The approach is by letting theta be equal to tan inverse of 3x. We let theta be equal to that. Clearly, you can see from here that this implies that tan theta is actually equal to 3x. At this stage, it's important for us to draw a right angled triangle where we're going to present this information tan theta equals 3x. That will be our theta, and we know that 3x can also be written as 3x over 1. And by definition, tangent of an angle in a right angled triangle, it will be the opposite side or over the adjacent side. So this will be 3x, and the adjacent side should be 1. And by Pythagoras theorem, the hypotenuse, you'll agree with me that it will be the square of this plus the square of that. And then we take square root of that. So square of 1 is 1 plus square of 3x is 9x squared. And then we take square root of that. That will be the hypotenuse. Right. But let's carry on with this one then. We differentiate both sides. And what do we get? Derivative of tangent is secant squared. So sec squared theta d theta. On the right hand side, it will just be 3 dx. Now divide both sides by 3. You're going to get sec squared theta d theta all over 3. The answer is going to be dx. Why do we do that? Because in the expression here, you see that's your dx, which is that one. It means in that place, we're going to put this expression here, and the whole of that will be replaced by theta. So now this integral, therefore, changes to the integral of theta times this expression, sec squared theta d theta all over 3. Now notice that 3 is dividing, so we can take 3 out because it's a constant. That takes us to page 2. On our page 2, if I put it like this, I think you can see that expression there. Yeah, you can. Let me just move this one down a bit. All right. So now we are saying this is the same as 1 over 3, the integral of theta, sec squared theta d theta. Now at this stage, we're going to say that we let this be equal to I for representing integral. And so you'll agree with me that this is basically 1/3 I. But we have to evaluate or determine what I represents. In other words, we have to perform this integration here. So we're going to say I is equal to the integral of theta sec squared theta d theta. At this stage, obviously, we're going to use integration by parts. So we let u be equal to theta, and remember, integration by parts requires us to say dv is equal to, in this case, we're going to say sec squared theta d theta. Differentiating both sides, we're going to get du is equal to d theta. If integrating both sides, we're going to get v equals the integral of sec squared is tan. Now, in this case, we are talking about theta, so it has to be tan theta. If you do not know how we get this from this one, please refer to some of the videos that are presented so far. We've had to explain how we obtain tan theta from sec squared theta when we integrate that. The answer is this one. The best way to prove this is to differentiate this. Differentiate this, you will see that the answer is that one. Maybe let me just do it as quickly as I may. So we are saying basically, suppose we have y equals tan theta. I am saying because the integral of this is tan theta, when we differentiate tan theta, we must get sec squared theta. All right, so what is this? This is sine theta over cos theta. We're saying y equals that. Let us differentiate it. What is dy d theta? Where dy d theta is going to be equal to, let me put this one straight. Dy d theta is going to be, remember quotient rule, differentiate sine, the answer is cosine, multiply by cosine, so it be cos squared theta, minus derivative of cos theta is minus sine theta, times sine theta, it will be minus sine squared theta, all over the square of the denominator, which is cos theta, and we square it. In the numerator, we have cos squared theta plus sine squared theta all over cos squared theta. And what is sine squared plus cos squared? As long as the angle is the same, the answer is going to be 1 over cos squared theta. And what is 1 over cosine? Secant. So this is basically sec squared theta. So yes, it is correct to say that the integral of this is tan theta, because the derivative of tan theta is equal to the integral is equal to the derivative of tan theta equals sec squared, and therefore integral of sec squared, it must give you tan theta. Right, let's carry on then. So we understand how that is obtained from that. So integration by parts formula, it says the integral of u dv is equal to uv minus the integral of v du. Now notice this part here. U dv is basically this expression here, because we said that's u and that's dv. So let's just rewrite it, which is our I, of course. So this is theta sec squared theta d theta must be equal to, what is u? Where u is theta. What is v? Where it's tan theta. Minus the integral of, what is v? Where it's tan theta. And then we are saying d theta. Now, the integral of tan theta, I'm going to explain to you shortly. Let me move back a little bit. So this is going to be theta tan theta minus the integral of tan theta is in fact the natural log of sec theta. And I'm going to explain to you shortly. So this is our I. We are supposed to place it back here and then put a constant there, and then move back from, go back to our original variable, because this is not our original variable. Our original variable is x. So we must go back to x by using this triangle here. I'm going to show you shortly. But now I want to explain, describe how we evaluate this integral to give us that. If I may get a separate page here, and here we go. So basically, I'm saying the integral of tan equals the natural log of the absolute value of secant. So we're saying the integral of tan theta d theta. By the way, this is enough to be in an exam as a question on its own, this one here. So how do we evaluate this? The answer is tan theta is sine theta over cosine theta. Remember this, d theta. And then we're going to let u be equal to cos of theta, differentiate both sides, du equals minus sine theta d theta. Now there's something here, multiply both sides by minus, you're going to get minus du equals sine theta d theta. Now this is your sine theta d theta there, and so this integral, therefore it must change to the integral of 1 over cosine theta. What is cosine theta? U. And then what is the sine theta d theta? Is minus du, and take the minus out. This will be minus the integral of 1 over u du. By now you should remember that this is actually minus natural log of u. Now the minus is actually minus 1. If you see what I mean, let me write on another page here. This minus here is the same as, are you able to see what I'm writing? Yes. This minus here, we can rewrite this to natural log of u to the power minus 1, like this. And what is this? Natural log of 1 over u, laws of exponents. What is this? Natural log of, what is u? Well, u is cos theta. Remember here, u is cos theta. There it is. So that will be 1 over cos theta. What is 1 over cos theta? Secant theta. So this is natural log of sec theta. So that's the integral of tangent. I was just showing you why this should be equal to this. Now let's go back to this point here. So we're going to say, therefore, our integral, therefore, where is our integral? Well, here is our integral. We're going to say, therefore, this one here, which is equal to 1/3 I, it will be 1/3 of this, and we're going to say plus a constant C, right, as follows. So we're now going to say on our page 3, we're going to say, are you able to see? Yeah, right. So we're going to say, therefore, our integral of tan inverse of 3x dx, which is equal to 1/3 I, is equal to 1/3. What is our I? I is this one here. You can see it, yes. Theta tan of theta minus natural log of sec theta, like this, and then we say plus C. Now let's go back to our original variable. What is our original variable? X. So we're going to get rid of theta. What is theta equal to? Tan inverse of 3x, or inverse tan 3x. All right, so this is going to be, and remember tan theta is 3x. So we write this one first. We write 3x, and then we write inverse that. So this is 1/3, or if you like, we can write it exactly how it is. Theta is equal to tan inverse or inverse tan 3x. So tan inverse of 3x. Remember, we're multiplying this by, so this is theta. What about tan theta? Tan theta is 3x. 3x minus natural log of, what is secant of theta? This is theta. Secant is hypotenuse of adjacent. Remember, it's the reciprocal of cosine. So it's it's square root of 1 plus 9x squared, square root of 1 plus 9x squared all over 1, which is just this one here. So it will be square root of 1 plus 9x squared, like this, over 1. It's the same expression. I'm going to put this in brackets like so, and then close the bracket, and then plus C. Now, we're almost done. So this one, we write it first. If I move back a little bit to make sure that I accommodate everybody in terms of all these terms here, I'm going to say this is equal to 1/3. Watch this. Inside brackets there, I'm going to start with 3x, and then I'm going to say inverse tan, or tan inverse of 3x. And then I'm going to say, watch this, I'm going to say minus natural log of, instead of having square root of that, I'm going to write it as 1 plus 9x squared, and then I'm going to say to the power half plus C. Why am I doing that? Because I want to apply the laws of logs. This must come here and multiply. So this is going to be 1/3 3x tan inverse, or inverse tan of 3x, and then minus 1/2 natural log of 1 plus 9x squared, and then I'm going to say plus C. Now let me distribute the 1/3 and get my final solution. So my final solution is going to be, the 3's cancel here, I'm going to get x, and then I'm going to say tan inverse, or inverse tan of 3x, and then I'm going to have 1/3 times half is 1/6, and then natural log of, and then I have 1 plus 9x squared, and then I'm going to say plus C. So this is my final solution to this question here. I told you these are very advanced questions on integration, and this is calculus B, obviously. If you're busy with calculus B, and I must emphasize this, that all these questions I'm going through right now are past exam questions. So if you're preparing for calculus B exam, please go through these videos very meticulously. Right, so we're done with question 1. I'm just looking for page 2, but it doesn't matter. So we're now on page 4, and I'm moving on to integral number 2. In this video, our integral number 2 is this one. We are from an indefinite integral, this one indefinite, and now no limits, and now we're going to a definite integral with limits 0 up to half of sine inverse, or inverse sine of 2x dx. We're supposed to evaluate this. The approach is basically the same as in the first one. So this is how we go about it. Page 4, let me capture question number 2 exactly how it is. The integral from 0 up to half of sine inverse, or inverse sine of 2x dx. Right, so the approach here, because this is a definite integral, I'm going to watch this, I'm going to let I be equal to the integral indefinite sine inverse of 2x dx. After evaluating this, after integrating that integral, I'm going to come back here and consider the limits, the lower and upper limit. So that's the best approach. If I don't want to change the variable, the limits of integration, then I can just go ahead and integrate an indefinite and then come consider the limits. So this is a wonderful technique. The approach is the same. We're going to let theta be equal to the sine inverse or inverse sine of 2x. This, you can agree with me, it implies sine theta is equal to 2x. And again, if you go back to a right angled triangle there, because we know we may actually need other trig ratios other than sine theta, and by definition, if we write this as 2x over 1, sine of an angle, if this is your theta, sine of this angle would be the opposite side. So that would be the opposite side, and the hypotenuse would be 1. So that would be opposite over hypotenuse. And therefore, by Pythagoras theorem, this side here should be 1 minus 4x squared. How do we get that? Well, square this, right, minus that squared and take square root. That would be the adjacent side. So it's the square root of 1 minus 4x squared. Now, let's continue with this one here. We differentiate both sides. Derivative of sine is actually cosine. So we have cos theta d theta. On the right hand side, we have 2 dx. Now divide by 2 both sides. We're going to have cos theta d theta over 2, and this is equal to dx. Right. Why are we doing that? Because this expression dx is your dx there. So this one here, remember, must be replaced by theta, and that our dx, this is what must come into that place there, or into this place. We're talking about this part here and that part, obviously, because that's our original integral. All right, so let's put this into that thing, taking us to page 5. So we're basically saying, if you follow what I mean, we're basically saying our integral I, therefore I, which is the integral of sine inverse of 2x dx, must change to, watch this, integral. Where there is this, I'm going to put theta, because that's my theta right there. There is my theta. So I'm going to have now here, so I'm going to have theta, and then in that place, dx, I'm going to put this expression. So I'm going to put cos of theta d theta all over 2, taking half out because it's a constant, 1 over 2, and then the integral of theta, cos of theta d theta. Again, we're going to let this be equal to, because we already have I here, I'm going to call this I1. So this is basically 1 over 2 I1, but we need to determine what I1 is. So I1 is equal to the integral of theta cos of theta d theta. Yes, we're going to use integration by parts. So let u be equal to theta, and obviously du equals d theta, and then we're going to say dv equals cos of theta d theta. The integral of dv is v. The integral of cos theta is actually sine theta. Please check that out. Now, going to integration by parts formula, what does it say? It says the integral of u dv is equal to uv minus the integral of v du. Now, watch this. You can see it here. Yeah, you can. Let me move this one down a little bit. Right. You can see it here. That will be u dv. Right. Can you see? Yeah, you can. So this is, we're saying, therefore, our I1 is equal to, what are we saying? We are saying theta here is going to be our u, remember? So we're going to say it's theta cos of theta d theta. This must be equal to, we are here. What is our u? Theta. What is our v? Sine theta. Minus the integral of, what is our v? Sine theta. And then d theta. And what is, so this is theta sine theta minus, what is the integral of sine theta? Do not forget that integral of sine theta is minus cos of theta. Now watch how I'm using brackets there. Theta sine theta plus cos theta. Now this is our I1. So we must come back here and say that we are basically saying, therefore, this integral here, which is our I, which is equal to sine inverse of 2x dx. This is where we're coming from. Remember, that's our I, simplifies to that, half of I1. And what is I1? There is our I1. So this is going to be equal to half of I1, and our I1 is this expression. I'm just going to go straight to say theta, sine theta plus cos theta, and then I must say plus c. But we must get rid of this variable, go back to our original variable. What is our original variable? Well, our original variable is x. So we are going to look for the relationship between x and theta, and we get it on page 4. Here we go. So theta is sine inverse or inverse sine of 2x. So this is going to be half. We are saying inverse sine of 2x. What is, so that is our theta. What is sine theta? I hope you can see what I'm writing. Yeah, let me move it up a little bit. Right. What is sine theta? Well, we can see it from here. Sine theta is actually 2x. So that will be times 2x. And then plus, what is cos theta? Well, cos theta, coming back here, cosine is adjacent over hypotenuse. So it will be this over that is basically this one. So that will be square root of 1 minus 4x squared. And then plus c. Now, let's distribute, let's rewrite this part here. This is going to be 1 over 2. And then I'm going to have 2x sine inverse of 2x plus square root of 1 minus 4x squared plus c. Let me complete this on page 7. Completing this, of course, this is a definite integral. We have to evaluate the integral. If we continue it here, I hope you can see what I'm writing there. I hope you can see. Yeah, you can. So this is going to be equal to, watch this, the 2's cancel. I have x sine inverse or inverse sine of 2x, whatever pronunciation or whatever, however you want to call it, plus half square root of 1 minus 4x squared. Now, the c has to go because now we're dealing with, of course, we can say plus c, but when we are considering the limits of integration, the c has to go. So we're now going to say, therefore, this integral from 0 up to 1 over 2 of sine inverse of 2x dx, this one here, must be equal to, remember this is where we're coming from, there is our integral that from 0 up to half must be this expression here. Watch what I'm going to say, x inverse sine or sine inverse of 2x and then plus half square root of 1 minus 4x squared, and then I'm going to say evaluating from 1 up to from 0 up to 1 over 2. Now we put 1 over 2 there, there, and there, simplify, and then we're going to say minus. We put 0, obviously this will collapse. If you put 0 there, it will collapse. If you put 0 here, this will be 1, and I'm just going to have half there. But let's do it slowly. So we're saying this is equal to 1 over 2, and then sine inverse or inverse sine of 2 times 1 over 2, and then plus 1 over 2. We're inside the square root sign now. 1 minus 4 times 1 over 2 all squared, right? I'm done with 1 over 2. Then I must come with 0 now, minus. Starting from there, it will be 0 sine inverse or inverse sine of 2 times 0, and then plus half, and then I'm saying square root of 1 minus 4 times 0 squared. Now watch this. This is 1 and the whole of this collapses because that's 1 minus 1. 4 times a quarter is actually 1. 1 minus 1, 0. The whole of this collapses. And here we have, so this will be half of sine inverse of 1 because that's 1. That's all we have left in there. So we're now saying this is 1 over 2 sine inverse or inverse sine of 1. And then we're saying minus. Now, let me put brackets there. This whole thing collapses, and here that is 1. 1 times half is actually half inside brackets. So the inverse sine of 1 is actually pi by 2 because sine of 90 degrees is actually 1. So the inverse sine of 1 is pi by 290. So this is going to be 1 over 2 multiplied by pi over 2 and then minus 1 over 2. This is actually equal to pi over 4 minus 1 over 2. Leave it like this. It's not necessary to try and simplify that. It's not necessary. That is our final solution to our integral. Remember, these are higher order questions. Like I told you, this is the integral we have been evaluating. Again, a past exam question. Right. Let's go to the last one. The last question we're going to work on is this one. Right. The last one for this video. The approach you guess is exactly the same. Likely this one is an indefinite one, so we don't have to worry about the limits of integration. The approach is the same. Let's go to number 3. Approach is the same. So this is the integral of cos inverse or inverse cos of 2x dx. Yes, we're going to say let theta be equal to cos inverse of 2x. This, you agree with me, means or implies that cos of theta is actually equal to 2x. Again, going to a right angle triangle and talking about theta in there. And this can also be written as 2x over 1. And by definition, cosine will be adjacent. That's your theta. This will be the adjacent side. The hypotenuse side must be that one. By Pythagoras theorem, this will be 1 minus 4x squared. Please convince yourself that this is correct. Because we square that, we square this, and we subtract this from that. This squared minus this squared, and we take square root of that to get the other side there. Right. Now, let's continue with this one here. We're going to differentiate both sides. Differentiating both sides, remember derivative of cosine is minus sine theta, and we're going to say d theta equals, on the right hand side we just have 2 dx. Divide by 2 both sides. This is going to be minus sine theta all over 2 d theta, and this will be equal to dx. Now, so this is taken care of. That is also taken care of. So this integral then changes to the integral of theta. Remember, theta is this one here. And then dx, I'm going to have this expression, minus sine theta over 2, and I'm going to say d theta, like this. We take the minus out, of course, together with the half there, dividing. Let's go to the next page. On our next page, we have, I hope you can see there. Let me move this one down a little bit. All right, so that's our page 9. So we're saying that is equal to minus 1 over 2, the integral of theta, sine theta, and d theta. Again, if I let this one be equal to I, so this is going to be minus 1 over 2 I. We must determine what I is. So what is I? Where I is the integral of theta, and then sine theta d theta. Integration by parts, let u be equal to theta and dv be equal to sine theta d theta. Differentiating both sides, du equals d theta. Integrating both sides, v equals the integral of sine is actually minus cos. Please take note of that, cos theta. Integration by parts formula, the integral of u dv equals uv minus the integral of v du. Substituting this part here, remember, is that, so I don't have to, I can just go straight and say this is equal to theta times minus cos theta, and then minus the integral of, here I'll be having minus cos theta, and then I have d theta there. These minuses will give me a plus sign, and so here I have minus theta cos of theta plus the integral of cos theta d theta. Right, you multiply those out. Now, what is the integral of cosine? Well, the integral of cosine is actually positive sign. So hopefully you can see what I'm writing here. You see that one there? Yeah, you can. I think you can see it. All right. So what I have now is, if I move down here, I'm going to say that is exactly equal to minus theta cos of theta plus, I said the integral of cosine the integral of cosine theta is actually sine theta. That's the integral of cosine theta, it's positive sine theta. So we have evaluated what our I is. So we're now going back and say, remember what we're saying? We're basically saying this integral is actually breaks down to half minus half I. So let's recapture our original integral then. Our original integral is this one here. So we're gonna say here, remember it's minus half I. What is our I? This is our I. So we're gonna say therefore our original integral is this one here. The integral of cos inverse of 2x dx is just equal to minus 1 over 2 I. This is minus 1 over 2. What is our I? Our I is minus theta, cos theta, and then plus sine theta. Now I must say plus c. Now distribute the minus half. This is going to be a half of theta, cos theta, because the minus is cancelled, and then I have minus 1 over 2 sine theta, and then plus c. Let's go back to our original variable, which is our original variable is x. Now, if you go back to where we started from, here we are. What is theta? It's the cos inverse of 2x, or inverse cos 2x. So this is 1 over 2 inverse cos 2x times, what is cos theta? Cos theta, if you can see it, cos theta here is 2x. You can see it there. Yeah, cos theta is 2x, and I must have 2x here. And then I have minus 1 over 2. What is sine theta? Coming back here, sine theta is the opposite over hypotenuse. So it will be this over 1. It's just this one here. So it's minus half square root of 1 minus 4x squared. And then remember plus c. Let's simplify this. This cancels that. So my final solution then is x inverse cosine of 2x minus 1 over 2 square root of 1 minus 4x squared plus c. That will be my final solution. Now, notice that these are not very friendly questions. They require a lot of patience, and the amount of work involved is quite a lot. Three questions, we've gone through 3 questions now, and it's just under 33 minutes. All right, this is where I'm going to stop in this video. And like I said at the beginning of this video, we definitely value your feedback. It helps us to plan on how we are supposed to present this information to you guys so that we cater for everybody. Yeah, so we appreciate your support in terms of subscriptions, sharing of videos, and commenting and liking our videos. We really value that. All right, integration by no means is exhausted. We are not done with integration at all. I have a couple more videos set in terms of work already prepared to present many more videos on integration, and then I also have some work on limits because we have quite a lot of work there on limits as well, and then applications, like I said in the last video, of differential calculus. All right, we will see you in the next video. God bless.